I'm gonna talk about my private playground because, like, for most of you, probably you work from 9 to 6 like me, and for a few people like me, the web is not over at 6. It just gets crazier. So tonight I want to share it with you and to show the work I do outside of the office, and sometimes in the office too, because I try to take my playground and put it in the office and tell my coworkers that it's fun and we could play together. So a bit of me, I'm Hoebregts, and no, I don't speak Dutch. Sorry for that, even my name seems Dutch. I'm from Brussels. And I'm currently a front-end developer at Base Design in Brussels. And I also teach generative design at Hoebregts. It's a French school in Namur. So I'm gonna talk within 3 steps. So I'm gonna start with CSS, then go with Canvas, 2D API, and I'll end with WebGL. You probably all know Star Wars. And you know those kind of transitions I really liked because it's like retro, even though it's still cool and the current movies, we still see them. So I wanted to do it in CSS. So here is the live demo, and to do it, I use the mask property. So the mask is actually a background you define, so it could be an image or a gradient, the same way you can define a gradient in a background image. And what I do is when the image is visible, and I switch in JavaScript for the between the images, I move the position of the mask. So I draw a big mask that is 3 times the size of my viewport, and the mask is actually from fully visible to half visible to fully hidden, and I just translate this mask. So if I change here, you can see that the red is actually the mask. So the mask is, when it's fully over, it's black. Actually the mask, you see it's fully black. And when it's black, the image is not visible, and as soon as it swipes, the image gets visible. So it's like I only transition one image, the one that gets visible, I move the mask so that it gets visible. The mask API CSS property is quite well supported beside Edge, even though it's coming in a couple of months, I hope so. So it's nice and it's smooth when you want to animate it. The second demo is one of the first I do with my students. It's pure CSS particles animation. I love emojis and I love particles, so this was for me the best demo I could make with them. And what I really like is that it's an intro for a Sass function, and it's really not the best way to do a particles animation because in my HTML I actually have 200 spans, so don't do it for a live project, but do it for fun. And the trick to get like random particles is that I play with the transform origin, so they all have the same animation that is just a pop, and the pop animation is just rotating from 0 to 220 degrees. And all the particles that get a random color that is coming from an array of colors. And the duration is also random, and I put a delay of -3 to avoid when you load the page that some particles are not yet visible. It's just to get a better look when you first load the page. But the transform origin is really the trick. So I get a random value from 0 to 400 pixels, and I add 100 pixels so that it's not rotating just next to the tada emoji. So if I update, for example, here the 400s and I put 200s, you'll see that the range is going to be shorter and the particles are thrown closer to the emoji. And since I really liked particles, I made a fully CSS 3D sphere, just because. And again, if you want to do 3D stuff, don't do it like this. There is a WebGL technology for it, but it's working, and it's working on all the browsers because 3D CSS is well supported. And again, I think I have 400 spans in this demo, so it's not a good thing to do. And again, I don't do it with my students because it's maybe a bit too math. So as you can see, I calculate like theta and phi and weird values. And it's actually just an algorithm to define position along a sphere. And what I do, I just take my 400 spans and I define their 3D position and I animate the whole sphere. But in CSS, there is one issue, is that everything is flat. So if you rotate something in 3D, at some point it will get hidden because when you take a paper and you rotate it, you don't see it anymore. So to avoid that, I actually apply a second animation on all the particles. So this is getting heavier for the browsers, but it still works. So I rotate the full sphere, and then every particle has a counter rotation. So it's like doing like this, you see? I'm really good at doing particles. So instead of doing like this, when you don't see me anymore, and then you see me, and then you don't see me, it's doing, okay, I think it's enough. And again, because I love particles, I made more 3D shapes in CSS, like a tube or a cone, or even a torus. I just took like algorithm I found online, so I didn't write them myself because I'm not that good at math. But since it's pure math, you can apply them to any kind of language you have, and CSS was fun for me to do. So I also play with Canvas, and I had a recent project, so at the office, where we wanted to have some kind of a fluid animation with balls, because the client had a video using this kind of blobs. So I, again, tried to find some logic in it, and some guy, luckily for me, already did it in processing. So it's a Java software language. And this is like the translation in JavaScript. And it's also based on a paper that is like Hailey, a university math guy who wrote it. So I didn't do all the math, but I came from here to this animation. And I needed to make it performant because it was going to be live and it's working on mobile. So the trick is that they all bounce to the walls, but when they bounce to each other, it's not like pure blobs physics. It's just like bouncing to each other in just like they push each other, but they don't like merge like drops could merge. So, but the performance is actually quite good on mobile, and we even have the gyroscope API to make them move when you move your phone. So people like to play with it. The barrier grid animation, it's maybe you had a book like this, or if you have kids, maybe you have one of those books. The principle of the animation is that we have frames where you cut them in like small stripes, and when you move a big paper with all the stripes, black stripes, it starts to move. So I tried to do it again using the webcam, because it's more fun with the webcam. So I have to move to make it work. So I'm just gonna move. So you saw that it took all the frames, and now when I start to move this kind of grid, I get the animation that plays. So when I click on the window, what I do is I take 12 frames. So that's why it takes some time. And then for every 12 pixels, the first stripe is the first frame, the second stripe is the second frame, the third stripe is the third frame, etc. And I do it like 12 pixels at a time, and I fill the window. And the black grid is actually just a background gradient, so that it's responsive and it works on all viewports and device. And so when I move my mouse, I get this animation. So it has no point, and it's completely useless, but maybe one day I'll use it for a project. But it allows me to work with the webcam API, which is nice because I think we don't use it enough, and we should record the people all the time on all the projects because it's nice to record the people using a website, even though we are not allowed to do it anymore. Well, you still have 10 days to do it, but after that, please stop. I love dogs. I'm really a dog person, but more than dogs, I love pixels. So I really like to play with the pixels. So for this demo, well, it's not moving, but I actually took the picture you saw previously, and what I do is for every pixel, I calculate the brightness of it. So you know that all the colors are not the same, have not the same brightness. So for example, yellow is more bright than blue or red. So it's not just a grayscale conversion. And then what I do is for every pixels, I define the rotation of a line based on that brightness. And it creates that kind of effects. So this one is not really impressive because it's not moving. But then if you want to go further, I created a half-tone demo. And here I'm creating particles because, like, as you know, I love particles. And I'm taking the same image, I calculate the brightness of every pixel, and then with my mouse I can make them move because make particles move, it's more fun. And because I played with webcam API previously, I did it with the webcam. It's not moving because of performance issue, but one day I'd like to make it move. So what I do is real-time pixel manipulation, and it's in Canvas, so it's not that good for the performance because it's using the CPU and not the GPU. So one day I'll try to translate it into WebGL so that I have more performance, and maybe I could make the particles animate. Yep, so pixel manipulation. Ah, shit. Yep. And then WebGL. I love illusions since I'm a kid. So I try to make them in WebGL. And for those kind of illusion, you need a specific camera. So basically in 3D, you get two kinds of camera. The first one is perspective, and it's like the view you get. So if I look at a square, I know it's perspective because like the further it gets, the smaller. The further it is, the smaller it gets. And this experiment is using Orthographic Camera. And in Orthographic, all the things have the same size. So even if one cube is further, it will keep the same size. And also the lines are not deformed. Like in real life, there is no kind of effects in them. So I could create those kind of animation with the orthographic camera. And when you click, you can see the perspective view. And you see that for this demo, I created some kind of cube with all those lines. And then I just applied here 2 small squares to make it an illusion. And I created a collection of these kinds of animation. For example, this one is maybe small, but in fact, there are a lot of hacks to make it work. So it's kind of fun to see that the big mesh, the big 3D shape is actually completely fucked up. And then I just apply a bunch of squares and it looks perfect. That's what I wanted to show to people, that life is sometimes just hidden behind squares. And that's another one. And also, I like tunnels, especially when I drive in a car. So I wanted to create these kinds of tunnels in WebGL. So I made a bunch of them. For example, this one, and when you click, it's getting like to the dark side, and you get. I made it like in a blood cell way, and when you click, it's like the microbes are getting like faster, and when you stop, it's like safe. It's red. But the trick here is that nothing is actually moving beside the particles you may see, but the shape of the tube is actually fixed. And I just make it move, but the camera is never moving. So for example, on the Star Wars demo, I just shake the camera to get a kind of a speed effect. But the shape of the tube is actually just the same, is always the same length, and I just morph it depending on the mouse. And that's how you can create this kind of moving forward effect without creating an infinite loop in the tube. So that's the kind of things I do in the night, and I like them because it allows me to just relax. And most of the time I don't get these kinds of effects, so what you saw is like a year or maybe 2 years of work, because most of the time I just get bad results, but even if it's a bad result, you always learn something, so that's why I really like to do them, because sometimes I get like a pen that's 2 years old, and a pen on CodePen, because I'm working mostly on CodePen, and I just updated it like 2 years ago because this was bad at the time, and now I know new things, and I'm better at CSS, I'm better at Canvas, and I can just improve it. So I think it's important to play with the technologies and to go further to what you can do, even if it's bad for the performances, like the CSS animation. I would never do it on a project like 200 spans. Like people would just scream at me on Twitter, like, "What is this shit? You should stop what you're doing. You're a bad front-end developer," whatever. But it's fun and it works. So that's it. So thank you.